So we are going to start a new data structure today, and that is called as linked list. Let's think from the perspective of a data structure like arrays. So forget linked list for a while. Let's say I declare an array of size 10 raised to power 5. Can you tell me what might not be so good about this? Or what are the shortcomings of using an array? In other words, under which circumstances you might not feel like using an array and using something else, dynamic insertion and everything. Because whenever you are supposed to declare an array, you have to predefine its size. Okay, if you do not predefine the size, then you cannot allocate an array. Now, one thing which is good is there is a malloc keyword, and using that malloc keyword, malloc or new, which perform dynamic memory allocation. So basically there are two kinds of memory allocation. First memory allocation is that which happens during compile time, when your code is compiling, and second happens during runtime. Okay, so what I mean by that is, let's say you have in your code int I comma j. Now when compiler is running, let's say your compiler is running, so it is trying to convert your code into a machine language code, machine level code. So during that point of time, it will perform these memory allocations. It will create a block of memory for I and another block of memory for j. Okay, so that is compile time memory allocation. But certain times you might want to declare an extra memory during the runtime. What is the meaning of runtime? Runtime means that now your code has compiled, and now your code is basically a process of operating system, and that process has started running. So that is what I mean by runtime. So during compile time, there is no process. There is your simple file, text file, which contains code, and that is being compiled by the compiler. But when compilation phase is over and runtime phase takes over, then your code is no longer just a code, rather it is an operating system's process. Okay, and that process at certain times might need to allocate certain extra memory depending upon the user's input. Okay, so for runtime memory allocation, this thing is also called as, when you have to do runtime memory allocation, this is also called as dynamic memory allocation. So now how to allocate dynamic memory? So have you guys used new keyword, new of something in C++ or Java? So this is exactly what this keyword does. So during the runtime, it can help you with an instance of some class or an instance of something else, whatever you require, right? So what actually happens is that in languages like C++ and Java, you have this new keyword, and in language like C, for dynamic memory allocation, you have got something called as malloc. Okay, so using that malloc, you can say that, hey, malloc of. So let's say during the runtime you want to declare enough space just for one integer. So I think one integer can fit into 4 bytes, right? So to the malloc, you have to just tell that, hey, this much amount of space I need, and then it will perform this memory allocation on your behalf and return you a pointer to this base address. Okay, so let's say if this byte location is 1000, or let's say 100, then this is 101, this is 102, this is 103. So all these locations, all these memory locations from 100 to 103 will belong to one integer only, but its base address will be 100, and that base address will be returned by this malloc. So first and foremost, you have to tell to malloc that how much memory do you need. Since you just need an integer, now the size of any data type can be retrieved by a very well-known operator called as size of. And here comes the data type. Yeah, so you can try using it. You can put size of int, size of float, size of char, and you will see that the size of char is 1 byte, size of int is 4, size of long will be different, size of long will be different, and so on and on. So to the malloc, you can just pass size of int, right? and this way it will return you the pointer to this thing. Now this malloc does not deal with the type of the pointer, because the pointers are different. Certain pointers are int star, and the character pointer is char star, and so on and on and on. So yeah, so this malloc does not know that what is the data type of the pointer, so you have to typecast it yourself, because you want to store an integer, so the address of that, the base address of that has to be stored in an integer pointer. So you can call it like this, and then you can receive it in this pointer. And now once you have this, then in this pointer you can put any value, whatever you want to put. So you can say that star of ptr is equal to 100 if 100 is the value that you want to put over there. Okay, cool. So please read about this operator. What is this operator? This is dereferencing operator. So using this, star of ptr means what? That in the address location being pointed by ptr, what is the value present over there? So whatever value is present over there, that can be dereferenced by using star ptr. So this was about the case when I wanted just one memory. What if when I wanted to allocate just enough space for one integer? What if I want to allocate space for, let's say, 3 integers or 4 integers? In that case, you simply have to multiply this thing with 3. If you want it for n integers, then you simply have to multiply it with n. Okay, so that way what would happen is that this block, every block will be of 4 bytes, and n such blocks will be allocated. So n such blocks will be allocated, and the base address of this thing would get returned to this, right? So what malloc does is, the memory that it allocates for you is a contiguous memory, one after the other, one after the other, and what it returns to you is the base address of this entire memory, which is this. And now you have to typecast it. Let's say you wanted to allocate for float, you have to do a float star over here and float star over here. One more thing to understand over here is, I think although when you study pointers you will get to know about this. Can you tell me why do I need a different data type for storing integer address, and a different data type for storing float address, and a different data type for storing character address? Can somebody answer me, why do I need it? Why can't I just store it in a generic type, in one common type? The base address is just an address, right? The base address is just an address. So if it's just an address, that address will be some hexadecimal kind of value, right? So why do I need int star to store address of integer, and float star to store address of float, and char star to store address of character? The reason behind that is because different data types, like integer, it has a block size of 4. Character, it has a block size of just 1. Long, it might have a different block size, and so on and on. Now, whenever you wish to move from one block to another block, you do ptr++, right? And this ptr++, when let's say ptr is 100, and let's say ptr is an integer pointer. So if you are doing ptr++, what will it become? Let's say it was 100 and you did ptr++. Can somebody tell me what will it become? Yes, it will become 104. It will not become 101, because 101 doesn't make sense. So whenever you increment a pointer, it starts pointing to the base address of the next integer. So doing something like this is, if you do ptr++, this is analogous to ptr equals to ptr plus size of that data type. And this thing will be different for different data types. For integer it will be 4, for character it will be 1. So these pointer based manipulations cannot be generic, because for different data types there are different memory requirements. So I need different int star, different float star, and different. So let us move ahead from here. Yeah. So see, I have seen that certain times what you guys do is, in your main function, you declare an array of size n. You do it, right? Instead of declaring an array of size 100, you declare an array of size n, where n is a variable, and of course you have this n predefined. Let's say this n is not predefined, pre-declared, okay, and then in the runtime you will just take this value, right? So I believe that you do this thing, instead of writing it here, you write it here. So you have an n, you scan this n, and then you declare this array. Okay, so there is this one piece of code, and then there is another piece of code where you do something like this. Now for this piece of code, it is guaranteed that the memory allocation of this will be a compile time memory allocation, because the size is pre-declared, right? So when the code is being compiled, the array of this particular size will be created. But what about this? Will this thing also be a compile time memory allocation? The answer is no, it will not be, because while compiler is running, it will not scan anything. Compiler does not scan anything, right? Compiler just translates your code from high level language to low level language. And when your operating system takes over, when it becomes a process, then things are actually scanned. So what you have written over here will internally be, broken down into something like this only. Okay, so these days I see people using this thing, but you have to be very aware of that thing, that whenever you are doing this thing, what internally happens is this. So we just saw an example of that, why dynamic memory allocation sometimes can be very important. Okay, one more thing. What if you have to do this thing again and again in the code? So your code is running, and let's say your user inputted, your user gave you some input, and to store that input you need to allocate an extra memory. You can always go to malloc, or you can do a new int, whatsoever. That way you will be able to just store that value at a particular memory allocation. One thing that we have learned is, if you are declaring a static array, or even if you are declaring an array in this manner, okay, once the space has been allocated, let's say this much of space has been allocated, then in the runtime you cannot allocate one more space over here. But if in the runtime I need to have space for one more integer, I just need to have space for one more integer or two more integers, can I somehow do that or not? I can do that. I can call a malloc, and that malloc will provide me with some memory location. Now that memory location needs not be contiguous to this. It needs not be contiguous to that. It can be allocated to you anywhere, here, anywhere. Can somebody tell me why? Why is it not possible for me to ask computer that, hey, you provide me this slot only? Have you ever seen a computer program which says that, hey, I need memory location 1000 or memory location 5000? Have you ever seen a computer program like that? You might never have seen, and you would never be able to see also, because you do not know that which memory location is being currently used by your computer or not. And that being the reason, it might so happen that the memory location which is just over here is being used by some other program, by Google Chrome or by your VLC media player or whatsoever. So you can't do that. So dynamic memory allocation, when you're calling malloc, so let's say you called malloc once, then whatever malloc will provide you will be a continuous chunk. But when you call malloc again, then it is not necessary that you will be provided from here to here. It is not necessary. You might be provided here, literally anywhere. So now my question is that, if let's say certain times what would happen is that I do not know how much of data is going to come, and I want to store that data in sequential order. What is the way to do that? How do we do that? And these things are very much, these cases are actually happening all over. So all of you guys have used vectors. Which kind of a data structure is vector? It is dynamic, right? It grows in its size. Similarly, an array list, that also grows in its size. So if all of us understand that, an important thing to get is, I'll just quote an example which I usually quote during classes on linked list. So just to develop the motivation behind that, let's say you want to travel, okay? You want to travel to your hometown, and let's say you want to book a bus ticket. If all the seats of that bus have already been occupied, will you be able to get a ticket? The answer is no. You can't get a ticket, right? But let's say you love traveling on train and now you just request a train ticket. Let's say all the bogies of train are filled, then railway ministry sometimes what it can do is it can insert a new bogie in between, at the front, at the rear, in the middle, anywhere, and you can get access to that seat. So that way, train that you have is dynamic data structure and bus is a static data structure. So bus is like an array where size is predefined. If the array is full, if the bus is full, it can't accommodate anything else. But train is like linked list. So even if something new comes, that can be accommodated by introducing a new memory at the front, at the back, somewhere in the middle, and so on and on and on. That is the main motivation behind linked list. So if you talk about a linked list, how is that going to look like? So basically, there has to be a data, some data. Let's say that data is integer. And for example, let's say data is equal to 4. Okay. So let's say user gave you this data and you created a node, and in that node, you put this 4. By node, I mean to say, for now, let's say you just requested memory location for an integer and you put 4 over there. Then user gave you 5 and then you put 5, and then he gave you 6, and then he gave you 7. An important thing is that you have been able to store the data, but you do not know what comes after what. Okay. So for that, what you need to do is you need to somehow link them. You need to link this to this, you need to link this to this, and you need to link this to this. Okay. So how can I link them? How can I link this node to this node? Let's say the memory location of this is 1000. Memory location of this is 990, and for this 800, and for this 2000. Let's say these are the memory locations. So how can I link them? So the answer is I can easily link them if I know the address of this thing here. So what I can do is that instead of just storing the data, I will also store the memory location of next node. So the memory location of next node is 990, that 990 is stored here. Similarly, memory location of next node is 800, so this 800 can be stored here. The memory location of next node is 2000, that 2000 can be stored here. And there is no next node to it, so for this, the other part will be null. Now if you are here, then you can always move here because you know that the address of next node is at 990, so you can go to 990. Once you are here, you know the address of next node is at 800, you can go there. You know that the address of next node is at 2000, you can go there. And here it is null, that means this marks the end of the list that I have seen. So what is this, guys? This is an address. And where do you store an address? In a programming language, where do you store an address? You store it in a pointer. Okay. Now, is pointer a generic data type? Pointer is not a generic data type. There are different pointers for different things. So if the data type of this thing is X, if this big thing, the data type of this thing is X, then I can store this thing in X star. Anyways, now any node that you see, I'm going to refer to this thing as a node. Okay. This has to contain two things with it. Okay. First thing is the data. That data can be integer, sometimes it can be float, character, string, whatsoever, right? And second thing that I would store is the address of the next node. So of course there are two things over here, so I need a struct. Let me call that struct linked list. Okay, and there is an data, and to store the address of this I need X star. And what is X? The type X is struct linked list. So I need struct linked list star, and I can call this thing as next. This is my next pointer. So this is my definition of a node of a linked list. So there are two things. First thing is data, and second thing is the address of the next node. And address of the next node is stored in this type. Now, because this is a struct type, so you can always define anything. Struct linked list. Let's say L. Can somebody tell me what kind of memory allocation is this? Is this a static memory location or a dynamic memory allocation? This is a static memory allocation, right? Because this is just like doing int x or int y, right? So this is static memory allocation. But if you want to perform dynamic memory allocation, then you have to either call new or malloc. Let's say you are calling malloc. In that case, it will return you a pointer, and that pointer, it will return you an address, and that address has to be stored in a pointer. So if you want to perform a dynamic memory allocation, first thing the type of this should be a pointer of that data type which you want to declare dynamically, and then whenever you wish to declare it dynamically, you have to call new of, let's say you are using malloc. You guys already know new. If you do not know, please learn it. Malloc, and then here you provide the size of whatever you want. So how you can provide that? You can simply call size of this thing, struct linked list, size of struct linked list. The moment this much of thing has been called, so there will be a memory allocation somewhere at, let's say, memory 500. Okay, these two compartments have got created, and now whatever is the address of this, which is 500, this address will be returned in form of pointers. So now you have to typecast it. So you will typecast it to struct linked list star, and then this thing will be allocated to L. So this is how you can perform the dynamic memory allocation of any new node of your linked list. And once that dynamic memory allocation has been performed, tell me one thing, can you access any variable of the struct independently? Can you access them without using the variable of this struct data type? You can't do that, right? So if you have to, let's say, access this, how can I access this? Do you guys know about dot operator? If, let's say, there was, instead of pointer, there was I do something like struct linked list p, then if I have to access this, I can simply do p dot data. So this dot operator is applicable on the direct data types of this. It is not applicable on pointers. If you have pointer, then you have to actually use that pointer in slightly different way. So for that, there is a very cool operator called as arrow operator. So if you do L arrow data, then you will know the value of this, and if you do L arrow next, then you will get to know the value of this, which is the next pointer. So doing something like, let's say this is your L, and the moment you do L equals to L arrow next, this is as good as migrating from here to here. Then again, if you do L arrow next from here, you move from here to here. Then again, when you do L arrow next from here, you come from here to here. So when you iterate in array, you keep doing I++, and when you have to iterate on linked list, you do L equals to L arrow next. This is the way to iterate across linked list. What is the most important part of a linked list? Let's say there are these 4 nodes. So which node should you know in order to visit the entire linked list? If I give you the address of this node, will you be able to visit the entire linked list? You will not be able to do that, right? Because you cannot go back from here to here. It is unidirectional linked list, which is also called as single linked list. So you need to know the memory location of this thing, and this is called as head. This is called as head of the linked list. So if you have the head of the linked list, then every time you can do head equals to head arrow next, head equals to head arrow next, and this is the way in which you will be able to traverse the entire linked list. What I can do is, let's say this is the case, okay? I'm going to write a code and you tell me if something will go wrong or not. So I'm saying that while head is not equals to null, because eventually my head will become null. When I come to this node and I do head equals to head next, it will become null. Okay, so while head is not equals to null, another way to write this thing is while head. So the meaning of this expression inside while is while this thing is not equals to null or this thing is not equals to 0. Okay, so in case of numerics, the meaning of this is this thing not equals to 0, and in case of pointers, the meaning of this thing is this thing not equals to null. So while this thing is not equals to null, what I'll do is first I'll print the data, which is cout head arrow data, and then I'll move my head by doing this head equals to head arrow next. Okay, will it be able to print out everything which are 4, 5, 6 and 7? Yes, it will be able to do so. Yeah. So if you do this thing, then the worst thing that is going to happen with you is that your head eventually becomes null, and now you do not know where your head is. So you should never ever pollute your head. You should always have the correct value of head in your program. If you do not have, then it's like you have lost the entire linked list. So that is a very, very important thing. So for that, what you can do is you can create another struct linked list star, call it temp, and temp equals to head. And now instead of iterating over temp, you can iterate over, instead of iterating over head, you can iterate over temp.